coming up on today's episode.
Good Tuesday afternoon to you all, YouTube. This is me at the computer once again. I'm going to call this the Wild Hair episode. I think you'll see why in just a second. But there was a question popped up on a video I did 4 years ago. And that prompted me to reflect a little bit more about this subject. And the video was on the, now I'm going to pop up the picture here. This device here, which is the Chicago Electric battery charger and engine starter, model 66783. You can see it as 6 and 12 volt. It's actually, if this thing works, it's a pretty decent charger. It does have a 55 amp, as you can see here, 12 volt or engine start function. It has fast charge at 10 amps, has float charge at 2 amps, and it also has fast charge at 10 amps on a 6 volt. So pretty decent little charger. And it, like I said, it has the function switch here, which is the charger and starter switch. One way puts it into charge mode over here, and the other one is the green one, just lines up there, and that's pretty obvious there. Now over here we have the charge rate meter. It goes from 0 to 15 amps, as you can see. And below that we have the red LED reverse connection indicator and the green charge complete indicator. Now those will become items of interest here in just a bit. All of this except for this part here. Now this part here is completely separate, the settings switch. This only has to do with the secondary side of the transformer, and that basically feeds the voltage into the circuit board that we're going to look at in just a second. So let's go for the next thing. Let's do a close-up. There you go. You can see the reverse connection, charge complete LEDs, the charge rate meter, and there is the close-up of the settings. And again, you can see all of the different settings. It's a decent charger if it works. And I keep saying that if it works. Well, you know what I'm getting to here. So now here's our actually our secondary side of the transformer. You can see the multi-taps. Now we have one center, or well, I won't say one center. We'll have one ground tap, and we have two others. We'll put the other side, 6 and 12 volts is what I'm going to say. And I'm not really sure if that's the case or not, but all this is wired into the switch here for the settings. And basically all of those do is feed this circuit board over here. And like I said, we'll see a close-up of that in just a second. But here's our primary side. See, this is our circuit breaker. Couldn't think of the name of it. For the battery charger. And like I said, that's what that is. And now, again, this is the primary side. This is the 120 volts input. This is I think a fusible type of deal here where, you know, it comes into one and doesn't come into the other. I don't know exactly how it works. But again, it is what it is. Like I said, I think we have one more picture here to look at. Yeah, there's our circuit board. Now, on our circuit board, we have several transistors, or what appear to be transistors, and there's your red reverse connection and your green charge complete indicators. And this item here on the heatsink is an SCR. Now that was deemed to be the bad component of my system when I was looking at it. And this is in fact from my video. But I did buy a supposedly good replacement for it and never could get it to work. And about that same time I bought a new Black & Decker, one of those fancy float charge automatic, whatever they call them, smart charger I guess is what you call it. and I haven't really looked back since. But now this, I got the wild hair part is, I got to thinking, now this is a perfectly good transformer in this unit, and like I said, it's a fairly hefty one, capable of 10 amps at constant rate, 10 amps of charging, and a burst of 55 amps. So I think this is well worth pursuing as far as maybe getting into this and maybe seeing if this could be fixed or refitted, I guess is the word. To that end, I have passed along some information to Bob. Y'all know Bob. Let me get another picture up here of the circuit board, or the schematic. Now you can see the circuit board schematic here for the charger. This is the actual hand-drawn circuit, and I don't know who did this. I found this on the page, and also Bob had sent me this originally way back when I made the video, and I have basically, it was a little bit slanted, and it's still just a little bit slanted, but it's much better than it was. And I also indicated some items here. Here's your start charge switch here, right there, and of course there's the SCR below that. Here's your green charge complete indicator on this side here. This is your red reverse connection indicator here. Here's your charge rate meter right there. All the N transistors are NPN. The P transistors are PNPs. And like I said, everything is indicated there. And so, like I said, I sent this to Bob again. I know he hasn't seen it for a while. And Bob had some things to take care of, and he said he would think about it. So what I've asked Bob is basically, is there any way to improve this circuit to where it will work? I mean, I did replace the SCR with what I thought was a known good SCR, and I did test that the same way I tested the original one, and it didn't work either. But I think that maybe the fluke meter that I was using wasn't putting out any kind of voltage that would trigger that SCR. That's my thought anyway. All right, so what we found on this charger is if I switch the start charge switch from charge to start, I would get output over here, okay? And I would, if I hooked it up to a battery, I would get some kind of indication here on the charge rate meter. Now, if we look at this circuit, now this wire here coming out of here is basically just a trigger for the SCR. It's on the gate actually, and when there's voltage present here, it goes through this 75 ohm resistor, triggers this SCR to basically change from no connection to connection, just like that switch would do. And there's no difference at all between flipping this switch and turning this SCR on. One thing does the same as the other. Now, the reason you get different outputs here is because of the settings over there that the switch that we looked at. If it's in start charge, or if it's in start mode, you would get that 55 amps here, okay? But if it's in charge mode, like 12 volt 10 amp or whatever, you would get 10 amps out here. So up to 10 amps, I should say. So that's the difference there. That's why these are identical as far as, in other words, if there's no kind of switch at all in this, then basically you're constantly getting a 55 amp feed out of this. So that's where the settings switch comes in and keeps your output under control a little bit because of the taps in the transformer itself. And I'd have to but I'd have to basically see how it's wired to know which taps do what. But again, like I said, that's what those do. Like I said, it is that's how you go from a start to charge, and that's how. But that's the only thing that SCR does, and I really don't understand why you really need the SCR. Because I think if this wasn't present and this was here, just a switch, then that would basically do the same thing. I would think. Maybe not the automatic part, I don't know. But again, Bob will have to correct me on this and I know he will. I do know that. But like I said, there has to be some way for this to sense. That's the only way I can think of saying it. Sense the fact that there is no need for the battery charger. It's full, and this would somehow turn off this SCR. But again, I don't understand how that works because I'm not smart enough to figure that out. That's the truth of it. So as I said before, I think this is the secondary side of the transformer. Now obviously this is not the switched part of it. There's a switch here to basically give you different outputs here, but they're all center tapped as you can see, and the 12 volts are coming out here, but actually it's more than 12 volts obviously, and these are full wave rectified to basically give you the output here. Again, this is part of the sensing circuit, I believe. And like I said, it would have to. Bob would have to explain all that to you. I couldn't. So, but anyway, like I said, getting back to it, in the short term, I think if you just left the start switch into start mode, this battery charger would be useful. I mean, it could be used. You just have to watch your settings and make sure your battery wasn't hooked up or when it shouldn't be or something like that. You know what I mean? You'd have to be more careful about it, obviously. But again, I think if it was set properly in the settings and you just turn the switch on, that would be basically the same thing as turning your charging on. So as long as this switch is in charge mode, it probably wouldn't do anything. Obviously it doesn't because we know that. So this is basically like an on-off switch. And again, that's how it would work. My way of thinking. Now, I said there's voltage here. Now I can't say that was the proper voltage. I don't know because again there may be problems over here, anywhere over here. Where the regulation comes into it or whatever it is, and that problem may be part of the original problem. I don't know, but again, whatever it is, I think. And again, I've asked Bob if he can either think of a way to redesign this circuit here to work or to design a completely new circuit for it. One that would basically incorporate all of the functions here. The only thing you'd really need is a charge rate meter. That's an easy one because it just fits between the output and the battery, and that gives you your charge rate. But obviously the rest of it, from what I understand, a battery charger will only charge a battery up so much that whatever it needs. In other words, a dead battery will need more amperage, and as it gets full, it takes less amperage. So that's what I understand. So really, you could actually run this thing basically with a couple of switches, to the proper, some rectification to the proper thing and do it that way. It would be pretty simple. But from what I've seen online, there's several circuits similar to these that you could use. And I'm trying to figure out if this is worth our while to basically make up a kit that could be used with this particular transformer or charger, because I know there are a lot of these. You can look at the comments, and when you put this Chicago Electric Model 66, you put that into Google, and you'll see a lot of responses, a lot of posts on forums about it. It doesn't work, it doesn't work, it doesn't work. And so there's obviously, a problem with this design that either causes it, not to work, or maybe it's just a bad design completely. I don't know. But whatever the case is, I think it could be made because, again, I need to stress this, that it does have a nice hefty transformer in it, and it has the indicators here, the meter, everything is there to make a nice battery charger, and one that could be used, unlike the smart chargers, to charge up a dead battery. The smart chargers won't do that. They will not function unless there's a certain amount of voltage present, and so you can't rejuvenate batteries, you can't do anything like that. But with something that like this that will put out a constant charge rate, even to a dead battery, then I think it's something that is useful. So again, I think that's what we're going to look at, and if I'm successful, or I say if we're successful in maybe coming up with something, either a fix for this, or a new circuit completely, or anything, I will let you know. I will post that in a future video and let you know for sure. But I like I said, when I got that question this morning, I know I didn't leave that video series up. I didn't finish it off properly. I'll put it that way, because basically when I got the new SCR in, I said to myself, well, if this works, it works. If it don't, I'm not worried about it, because I got a new charger. And so I said, basically, heck with the rest of you. So, like I said, I didn't mean to leave people hanging and things like that. So that's one of the reasons I'm kind of going back into this and looking into it. And if Bob doesn't want to help me on this, that's fine. I can get online and search for battery charger circuits, and I've already found a few of them, and that could, I think, wire up to do the job. And again, like I said, I'd rather have something a little more sophisticated, something like this. This is not an overly complicated circuit. I'm not saying that I could come up with it, but I'm saying that looking at it, it's just not that big a deal as far as circuits go. So again, full wave rectification here. That's where you get your voltage from and that goes, for anybody that doesn't know, that is going directly to the output. There's no ifs, ands, or buts. There's no resistors, no nothing there. Now there's obviously a bunch here, but basically these are sensing circuits. And you know what I'm talking about there. They're just taking what's here and putting it through more circuitry and coming up with sensing. If none of this was there, then it would basically go out the thing as whatever it was. So again, it can't be that complicated, I don't think. So again, like I say, that's what we're going to look at, and if I get somewhere with it, that's good. If not, well, I tried. And that's all anybody can do, I guess, is try. So again, like I say, we're going to leave that here. And if you guys have any suggestion, comments, whatever on this video, you think this is a bad idea, let me know. I don't care. Again, like I say, it's just something I didn't want to leave hanging. And again, I kept meaning to get back to this. You know how it is. You basically get away from something, and I do this all the time. You guys know, if you've watched my channel for any length of time at all, you know that I basically get fed up with something, or I get tired of messing with it, or whatever the case, I go on to something else. And that's just the way I've always been. And I'd like to, when I have something that's basically workable, like this old battery charger, you guys saw it when I did it in the original video. This thing was like brand new. It's never been used. I think I used it when I first got, I got this when I first got my Buick, and I used it to get that started a couple of times because it had the starter function on it, and I used it to boost the battery to start the car, and it worked fine. But as far as charging the battery, I never tried it much. And I can't say that it even worked from the beginning. So it may have been bad, whatever the circuitry is, it's bad. If it's the SCR or some of the rest of this is bad, then that may have been it. But again, we know pretty much that the SCR is not working because, again, we don't get any output when it's in charge mode. So if you've got a battery hooked to it, you should get some kind of output. And if you don't, well, I don't know. Like I say, that's just it. I think this is one of the battery chargers that has to be hooked up to a battery to have indication here of charging. But again, like I say, I had it hooked up to a battery, and in charge mode, nothing happened here. In start mode, I got indication here, and I did get voltage here. So then you know that it is working. Now, I think that's one of the things I think about this start charge switch. And I know I'm flapping a lot, but hey, I'm just thinking of things as I go through this. But I think that's one of the things with this start charge switch, that if you flip this switch, you're going to get voltage here and you're going to get indication here, because you don't have to have a battery then. Okay, you don't have to have anything to do that. But in order to get this SCR to work, you have to have a battery here. It doesn't work without voltage. So again, like I said, that's the way I look at that, and that's the difference between that. So, correct me if I'm wrong, but like I said, that's just the way I see it. I can't see throwing this thing away, saying it's no good when it's got a perfectly good transformer in it, I think. And all the rest of the stuff seems to be working, because I've seen the meter move. I know it moves. I didn't try hooking up the battery wrong to see if the red indicator worked, and I don't recall that I've ever seen the green charge indicator work, to tell you the truth. So again, like I said, it may have never been working. I know there was a couple times that I hooked it up to a battery to charge it. It didn't seem to do anything. So that's pretty good indication it's not working. So anyway, there you go. That's my wild hair for today. And I don't know when this will be posted, but I thought I'd throw it up there and run it up the flagpole and see if anyone salutes, as they say. So you guys have a great day. Thank you so very much for watching, and we will see ya.